5 galaxies are smashing into each other, and this is happening less than 1 billion years after the Big Bang. That's the finding. And to me, this is one of the most genuinely surprising things Webb has shown us yet. Let me explain what was actually found, why it's so unexpected, and what it might be changing about how we understand the early universe. So first, the basics. The James Webb Space Telescope spotted a group of at least 5 galaxies that are actively merging together. Not finished merging, not about to merge. Actually, in the middle of it right now. Well, right now, in the sense that we're seeing light from 800 million years after the Big Bang. The universe today is about 13.8 billion years old, so we're looking back to when the universe was barely 6% of its current age. That's extremely early. And astronomers named this system JWST's Quintet. The study was published on January 29, 2026 in Nature Astronomy by researchers at Texas A&M University. Hu, Popovich, and their team. What I want to make clear is that 5 galaxies colliding together is not a small event. It's one of the most complex, large-scale things galaxies can do. And seeing it this early? That was not on anyone's prediction list. Here's what the old understanding was. Before this discovery, the general thinking was that complex, multi-galaxy mergers, the kind where several large galaxies slam into each other at once, should take time to happen. The universe needs time to build galaxies big enough to collide meaningfully. The thinking was that you wouldn't see these kinds of large, chaotic, multi-galaxy pileups until well over 1 billion years after the Big Bang. Maybe 1.5 billion years. Maybe 2. The universe needed time to grow up enough for that kind of complexity. This is confirmed science. This was the working model. It wasn't just a guess. It was built on decades of computer simulations, observations from older telescopes, and our understanding of how gravity pulls matter together over time. So the expectation was clear. Early universe, simple structures. Later universe, complex structures. Then Webb looked. And what it found was 5 galaxies, already merged or actively merging, at just 800 million years in. That's hundreds of millions of years earlier than the models expected this kind of complexity to exist. To me, the word that keeps coming to mind is ahead of schedule. The universe apparently didn't wait as long as we thought. Now here's where it gets even more interesting. It's not just that 5 galaxies are merging early. It's what the merger is already doing. This system is spreading heavy elements, and when I say heavy elements, I mean things like oxygen, far outside the boundaries of the individual galaxies themselves. Let me explain why that matters. Elements like oxygen don't just appear out of nowhere. They're created inside stars through nuclear fusion. Stars burn hydrogen and helium, and through that process, they build heavier elements: carbon, nitrogen, oxygen, and more. When stars die, especially in large explosions, they throw those heavy elements out into space. Over time, those elements get spread around. The thing is, to have a lot of heavy elements spread far and wide, you need a lot of stars to have already lived and died. That takes time. That takes generations of star formation. And to already be seeing oxygen spreading beyond the edges of these galaxies at just 800 million years after the Big Bang, that tells us these galaxies were building stars fast and furiously, very, very early. And the numbers confirm that. The star formation rate in this merging system is roughly 250 times the mass of the Sun per year. What I mean by that, each year, this system is turning gas into new stars at a rate equal to 250 suns being created from scratch. To put that in perspective, our Milky Way today forms stars at a rate of maybe 1 to 3 solar masses per year. This system is doing it at 250 times that rate. That's not just a little elevated, that's extreme. And it's happening at a time when, by the old models, galaxies should still be relatively simple, small, and calm. This is confirmed data from the Webb telescope. It's not theory. The star formation rate and the presence of oxygen spread beyond the galaxies. That's what the observations show. Now let me explain the part that I personally find most mind-bending. This discovery might actually help solve a different mystery that Webb has been creating. Since Webb launched, it has kept finding something odd. There are large, massive, dead galaxies. Scientists call them quenched galaxies, visible in the early to middle age of the universe. Dead, in this context, means they stopped forming stars. They used up their gas. They went quiet. And they're bigger than they should be for their age. The puzzle has been, how did these galaxies get so massive so fast and then just stop? What burned through all their star-forming gas so quickly? The current theory, and I want to flag this as a theory, not confirmed, is that intense, chaotic periods of star formation early on could be the answer. If galaxies merged together early and created extreme bursts of star formation, they could burn through their gas supplies at insane rates. Once the gas is gone, star formation stops. The galaxy goes quiet. It goes dead. So what this newly discovered quintet might be showing us is one of these extreme early bursts in action. We might actually be watching, right now, the process that turns a young, active galaxy system into one of those large, dead galaxies that appear later. Some scientists suggest this could be a missing link between the wild early universe and the large, quiet galaxies we see in later epochs. I want to be clear, that connection is still being studied. It's a strong hypothesis, but it's not confirmed yet. It's the kind of thing that needs more observations and more data. What is confirmed is that this merger is happening. It's early, it's extreme, and it doesn't fit the old timeline. So what does this mean for the models? The way I understand it, this forces astronomers to go back and look at their simulations of how the early universe grew. If complex mergers were already happening at 800 million years, the models need to explain how. Either dark matter halos, the invisible scaffolding that galaxies form inside, grew faster than we thought, or the conditions right after the Big Bang were more efficient at building structure than we assumed, or both. Some scientists suggest it might be a combination of factors that let some regions of the early universe grow up much faster than average. That work is ongoing. What I find important about Webb as a whole is that this isn't the first time it's pushed the clock back on something. It's found massive galaxies earlier than expected. It's found signs of structure that shouldn't be there yet. And now, it's found a full 5-galaxy merger earlier than anyone's models predicted. There's a pattern here. The early universe was more active, more structured, and more complex than our old models assumed. To be clear about what this doesn't mean the Big Bang model is wrong. The Big Bang is not in question. What's being updated are the details of how fast things grew inside that framework. The timeline of complexity is shifting, not the foundation of cosmology. I also want to mention one more thing, because I think it adds to how significant this observation is. When astronomers find a system like this, they can measure its light. Light from oxygen, from hydrogen, from various elements gives off specific frequencies. By reading those frequencies, a technique called spectroscopy, they can confirm what elements are present, how fast things are moving, and whether these galaxies are actually merging or just appear close together from our angle. These are real measurements. The merger is confirmed. The element spread is confirmed. This isn't just a picture that looks interesting. The fact that this came out in Nature Astronomy, one of the top peer-reviewed journals in the field, means it went through serious review. Other scientists checked the methods, the data, and the conclusions before it was published. That matters. What I also noticed, going through the details, is that the name JWST's quintet is a clear nod to Stephan's quintet, which is a famous group of interacting galaxies much closer to us that was also imaged by Webb. It's a bit of a tradition in astronomy to name things after earlier, similar findings. But JWST's quintet is happening in a completely different context, far earlier, far more extreme, and far more surprising in terms of timing. One more thing I want to explain clearly, because I think it's easy to misread. When we say these galaxies are colliding 800 million years after the Big Bang, we don't mean it happened recently. We mean that the light we're seeing left those galaxies when the universe was 800 million years old. That light has traveled billions of years to reach us. We're not watching a live event. We're seeing a snapshot of something that happened long ago. But that snapshot is real. That's what the universe looked like at that moment. And at that moment, 5 galaxies were already mid-collision. The fact that Webb can see this, can resolve 5 separate galaxies this far back, can measure oxygen spreading beyond their edges, can calculate how fast they're making stars, that on its own is remarkable. 10 years ago, we couldn't have confirmed something like this. We would have seen a blur. Webb changes what we can actually verify. For me, the main thing I take from this is not just something surprising happened. It's that our map of how the universe grew up is being redrawn. We thought we knew roughly when complexity arrived, and now we're finding it showed up much earlier than expected. That means there's something we're missing.